Fire is the only thing that separates you from the freezing void. In dry conditions, anyone can light a match, but when the forest is soaked, the ground is covered in 3 feet of melting snow, and your hands are numb, fire becomes a mathematical impossibility for the unprepared. Wet snow is the ultimate fire destroyer. It attacks your heat source from below. It smothers your oxygen from above, and it soaks your fuel from all sides. Today, I am not just teaching you how to light a fire. I am teaching you how to manipulate the laws of physics to generate heat in a wet environment. We are going to cover the hydrodynamics of melting snow, the chemistry of true resins, and the structural engineering required to keep a flame alive in a blizzard. You need to watch until the very end because secret number 10 is the grand finale. It is a method that requires no spark, no flame, and no effort, just a violent chemical reaction that looks like magic but can burn your skin off if you disrespect it. Let's get to work. Number 1. The floating raft. Most rookies make the lethal mistake of clearing a little patch of snow and building their fire right on the ground. Here is the physics of failure. Even if you dig down to the dirt, the ground is frozen and wet. But if you build on top of the snow, the heat from your initial flame immediately melts the snow beneath it. This creates a pool of freezing water. Your fire literally sinks into this meltwater, hisses, and will extinguish itself forever because you didn't understand thermodynamics. The pro solution is to build a floating raft. Before you even strike a spark, you must construct a solid platform. Cut green logs which won't burn easily, or peel large slabs of thick bark. Lay them side by side on top of the packed snow to create a floor. This platform acts as a thermal shield. It separates your fragile coals from the melting snow below. Your fire stays dry, and oxygenated. If you don't build the raft, you don't have a fire. Period. Number 2. Heartwood surgery. You walk through the forest and everything looks soaked. The bark on every tree is black with moisture. You think there is no dry fuel. You are wrong. The science of wood is that it acts like a sponge, only on the outer layers. A standing dead tree might be soaked on the outside to inches, but the core of the heartwood has been sealed off from the elements. It is bone dry. If you try to burn the wet sticks, you find on the ground you are just boiling water. You need to perform surgery. The pro solution is batoning. Take your survival knife and a heavy stick your baton. Find a standing dead tree, never one lying on the ground. Cut a section, stand it upright, and drive your knife through the center to split it open. The wood inside will be light colored and dry. This is your fuel. Discard the wet outer bark and use only this inner gold. You have to work for it. The dry fuel is always there if you have the tools to access it. Number 3. The surface area hack feather sticks. So, you have your dry heartwood, but it's a solid block. You can't light a log with a match. Here is the physics. Fire needs surface area to propagate. A solid block of wood absorbs heat slowly. In a wet environment, the ambient moisture sucks the heat away from your flame faster than the wood can catch fire. You need to tip the scales in your favor. The pro solution is the feather stick. You need to take that dry heartwood and shave it into microscopic, paper-thin curls. Do not slice them off. Stop your knife just before the ends of the curls stay attached to the stick. These thin shavings have massive surface area relative to their mass. This means the friction of your knife heats them up, and they dry out almost instantly. They will catch a spark from a ferro rod when nothing else will. It is a tedious skill to master, but it is the difference between survival and failure. And speaking of chemistry, wait until you see the volatile reaction in number 10. It makes feather sticks look like child's play. Number 4. Nature's napalm birch bark. If you are lucky enough to be in a forest with birch trees, you have won the lottery. The science behind birch bark is a compound called betchlin. It is a hydrophobic oil found in the white, papery cells of the bark. This oil is highly flammable and completely waterproof. You can literally pull a piece of birch bark out of a stream, shake it off, and it will burn. When it burns, it produces a thick, black smoke that is the oil combusting. The pro solution: don't just light a flat sheet. Tear the bark up into a chaotic ball of fibers to increase surface area. When you strike it, it burns with the intensity of jet fuel. It is the perfect accelerant to dry out your damp kindling. Always carry a pocketful of this stuff. It weighs nothing and burns like gasoline. Number 5. The resin gold fatwood. Sometimes you need more than just paper bark. You need sustained chemical heat. You need fatwood. Here is the biology. When a pine tree dies or a branch is injured, the tree pumps resin sap to the wound to seal it. This resin is essentially solidified turpentine, a highly flammable hydrocarbon. even after the tree rots away. The resin-saturated wood remains because resin is a natural preservative. The pro solution: look for the joints where old branches met the trunk on rotten pine logs. These knots are often rock hard and smell strongly of turpentine, that is fatwood. Carve some shavings from this because it is saturated with chemical fuel. It is waterproof and burns hot enough to dry out damp twigs placed on top of it. It is nature's fire starter. But even fatwood requires a spark. The method in number 10 requires nothing. It's a chemical magic trick that is almost too dangerous to use casually. Number 6. The upside down fire. In wet snow, the traditional TP fire structure often fails. The physics problem is that heat rises. If you build a fire on wet ground, the heat goes up, and the wet logs on the bottom just sit there in the cold, never drying out. They act as a heat sink. The pro solution is to invert the physics. Build an upside down fire. Lay your largest, wettest logs on your floating raft first. Then stack smaller logs on top. Finally, build your small tinder fire on the very top of the stack. As the small fire burns, gravity pulls the hot coals and embers down into the layers below. The radiant heat travels downward, pre-drying the large wet logs before the fire even reaches them. By the time the fire drops to the bottom layer, the wood is dry and ready to burn. It is the most efficient way to burn wet wood. Number 7. The Spruce Gum Grenade. If you can't find fatwood, look for the fresh wounds on living spruce or pine trees. The sensory experience: you will see globs of sticky, golden, or white sap oozing from the bark. This is spruce gum. In the cold, it freezes hard like a rock. Most people ignore it. The pro solution: pry these hardened lumps off the tree. They are essentially solid balls of fuel. When you add them to a weak, struggling flame, they don't just burn, they melt and boil. They act like a long-burning candle wax, extending the life of your tinder bundle by 5 or 10 minutes. This extra burn time is critical when you are trying to get damp twigs to reach their combustion temperature. It's a time extender. Number 8. The Pocket Bellows Injection. You have a small ember, but it's dying. The wet air is suffocating it. The physiological pain: you get down on your knees and blow on the fire, but your breath is humid. You are blowing moisture onto a fire that is already struggling with water. Plus, the smoke blinds you, and hyperventilating in the cold makes you dizzy and weak. The pro solution is the Pocket Bellows. This is a collapsible metal tube, or even a hollowed-out piece of elderberry branch. It allows you to inject a concentrated stream of high-velocity oxygen directly into the heart of the fire from a safe distance. Oxygen is the third leg of the fire triangle. By compressing the air, you increase the heat intensity dramatically, turning a dull red coal into a white-hot blowtorch that can dry out wet tinder instantly. It is a surgical tool for fire. Don't leave home without it, because if you lose that ember, and you don't have the chemical knowledge I'm about to show you in number 10, you might not get a second chance. Number 9. The Canoe Bark Shield. You have your tinder ready, your spark is ready, but it is snowing heavily. Every snowflake that lands on your tinder bundle is a drop of water that kills your spark. The strategic failure: you try to shield the fire with your body, but the wind swirls the snow around you. One lucky snowflake hits your ferro rod spark, and it's game over. The pro solution: find a large, curved piece of bark. Set up your tinder bundle on your raft. Before you strike, place the bark over the tinder like a canoe or a roof, leaving just enough space for your hands to work underneath. This mechanical shield blocks the falling snow and wind, creating a dry microclimate for that critical first second of ignition. Once the flame is established and strong, you can remove the shield or feed it into the fire. Number 10. The Chemical Volcano. This is the grand finale. This is for when your hands are too frozen to hold a knife, your lighter is dead, and you need fire now. Here is the concept. It is a hypergolic reaction. We are mixing the stable chemicals to create a violent, spontaneous exothermic reaction. The ingredients: potassium permanganate, a purple crystal used for water purification, and glycerin, a common liquid found in medical kits or skin lotions. The execution: pour a small pile of the purple crystals on a rock or a piece of dry bark. Make a small depression in the center. Carefully drip. Do not pour a few drops of glycerin onto the crystals. The reaction: wait for about 10 to 30 seconds. Nothing will happen. You will think it failed. Then it will start to smoke. Suddenly, it will erupt into a violent purple and white flame that burns at over 1,000 degrees Fahrenheit. It creates instant fire. The warning: this is dangerous. The reaction is chemically aggressive. If you get this mixture on your skin, it will cause severe chemical burns. Do not breathe the smoke. Use this only in a true emergency when mechanical methods have failed. It is the ultimate cheat code for winter survival. Fire is not luck, it is a science. Master these 10 secrets and you can burn the snow itself. In the next video, we will dive deep into winter navigation, how to read the terrain when everything is white. Subscribe so you don't miss it. Stay warm and stay safe.